In this video, we're going to go through spectroscopy and the electromagnetic spectrum. So the electromagnetic spectrum consists of what we can see, visible light, which is from 400 to 750 nanometers, and also what we can't see. So going smaller, we have ultraviolet light, X-rays, gamma rays, and going longer, we have infrared, microwaves, radio waves. So a lot of these you've heard before, but this is the entire electromagnetic spectrum, and we're going to be doing a little bit with this. Okay, so spectroscopy is a method of analysis which is based upon the absorbance of electromagnetic radiation, or EM for short, by matter. We use this to acquire data pertaining to the structure of a molecule or the concentration of a species. Okay, so here's a diagram, and three things happen. So first, we have the intensity of the radiation that's propagating through the air. And then we have a sample right here. Okay, so this can be whatever. So something that's going to allow the electromagnetic radiation to go through it. So our intensity that we start with is going to be different from the intensity that's striking our sample and going through the sample and then exiting the sample. Okay, so just like if you were running and then you ran into, I don't know, a lake or something, the lake's going to slow you down, and then when you get to the other side of the lake, you're going to be tired from swimming through that lake, and you're going to be moving at a different speed. So just like us, when we travel through different medium, our speed changes. The same thing happens to electromagnetic waves. So there are two methods that we're going to talk about for spectroscopy: ultraviolet or visual spectroscopy. So when we use this type of spectroscopy, we're examining transitions in electronic energy levels. We use this to probe the electronic structure of certain compounds, and it's used to determine concentrations of solutions that contain certain compounds. So this one's pretty cool. We actually have a device that we're going to be using in class to do a lab with this to determine the concentration of something just based on what we measure in the lab. And it's pretty accurate. The other one that we have is infrared spectroscopy, and this examines transitions in molecular vibrations. It's used to detect the presence of different types of bonds and to identify molecules. Okay, so for the type that we're going to be using, ultraviolet or visual spectroscopy, an absorption spectrophotometer is used to measure the absorbance of a sample at wavelengths between 200 nanometers and 800 nanometers. So that's visible light. The peaks represent wavelengths that correspond to the energy associated with possible electronic transitions within the molecule. We're not going to do much with these right now, but these are the three formulas that we're going to be using for this spectroscopy to do our calculations. The other type of spectroscopy that we have is infrared spectroscopy. All covalent bonds in molecules are vibrating, constantly moving. Bond length is the average distance between the molecules. Covalent bonds have a vibrational frequency that is in the infrared region of the electromagnetic spectrum. Infrared radiation of exactly the same frequency will be absorbed by the molecule. Vibrational frequencies depend on the mass of the atoms and the strength of the bonds. Frequency is related to wavelength using the formula C equals V. So this is what I'm talking about with those bonds. They're going to be constantly moving in and out, in and out.